Hey guys, my name is That Quiet Kid, and today we are going to do a room on Tryhackme, that is Capture the Flag, a beginner level CTF challenge. So let's dive right into it. So it consists of four tasks, and the first task is translation and shifting. Translate, shift, and decode the following. Answers are all case sensitive. So the first question is, I think it's quite visible. It is written that can you capture the flag? So let's try this. The flag. It is the right answer. So the next question, I think it is in binary. So I'm going to use a website for this, that is CyberChef. Just paste the input, and I think it's binary, from binary. Let's convert this and let's try some binary out. Okay, so the next one is, whenever I see this equal to sign at the end of any hash or any encoding, I always go for base. I think it might be base 64, or maybe it may be base 32 or any other base, but I think it is some kind of base 64 or base 32. Let's check this out. I will include the link for this CyberChef website in the description of this video, and it is, I guess, let's try base 32. Okay, I told you, I whenever I see equal to sign at the end of any hash, I first of all, the first thing that comes to my mind is it's either base 64 or other base 64 or base 32 or any other. So the answer for this question is base 32 is super common in CTFs. Again, this hash again looks like it has two equal to sign at the end, so I think it might be base 32 or base 64. Let's try this out. Let's try if it is. No, it's not base 32, so let's try base 62. It is not base 62, and let's try base 64, and I think it is base 64. Each base 64 digit represents exactly 6 bytes of data. So the answer to this question is this. Okay, the next one is 6865, and it has 3 and an F in it, so I think it is in hex. So let's try this. I think it is hex, because as you can see that it has decimals and F at the end. If the F was in between, it doesn't matter, but if it has F in its hash, then it is a possibility that it is hex. F, as we know that in decimal we count to 1 and 1 to 9, and in hex we, after 9 we count to A, B, C, D, E and F. Up to 15 we count in hex. So from that I know that there is a possibility that it is in hex. Let's try this. Hex. I think it should work. Hexadecimal or base 16. Let's check if this is the correct answer or not. Yes, it is the correct answer. The next one is EVG something and 13. It has a number in it, and It looks like some kind of rot. So let's try it. Rot means rotation cipher. It looks, because it has a number and some alphabets, and I think it is rot. Let's try rot 47 first. So it's not, it doesn't make sense, so I think it is not rot 47. So let's try rot 13 and rotate me 13 places. I told you rot stands for rotation cipher, and when I see the 13 number in it and some alphabets, so I, the first thing that came to my mind is was that whether it is a rotation cipher or not. So it is a rotation cipher. Okay, so the next one is quite weird. I have no idea what this is, but let's try. Let's try rod 30 here. Again, no, it is not rotation 30. Let's try rod 47. Okay, you spin me right around, baby. Right round. You spin me right round, baby. Right round 47 times. And as you can see that it looks like Morse code, because let me explain you how I know Morse code. This is what Morse code looks like. These dots and line, through these dots and lines we represent Morse code. So that's how I know it is Morse. It is Morse code. From Morse code. Telecommunication encoding. Okay, so the next one is a bit trickier because it is some decimals. I think it is in decimal. Decimal. From decimal. Okay, unpack this BCD. Okay, so it was in decimal, so I was right. BCD. It's also, I guess, some kind of, what is BCD? Let's see. Binary coded decimal. So I was right. It is some kind of decimal. Okay, so the last one is, I think, quite large. Let's copy this. Okay, so again it is quite large, but it has an equals to sign at the end. So the first thing I will try is base. I think it is base 64. Base 64. Okay, now it has converted this base 64 into Morse, I think. Morse code. I think this is in Morse now. It should be. Yeah. Now it has converted this into binary. From binary. Okay. So again, what is this? Maybe it is some kind of rotation. Let me see it again. Fe, then then a dash, and ev. Let's go for rot. Okay, it gives us a valid output, and I think it is in decimal or maybe ASCII. Let's try rot 30 first to be sure. No, it is rot 47. Let's copy this and let me see the output again. It looks like decimal, so let's try decimal first. From decimal. Let's make this. So I was right. This is in decimal. Let's make this a bit trickier. So this is the answer for the last question from task 1. Okay. So we have completed the task 1 of this capture the flag beginner level CDF challenge. Let's now dive into the second part, which is spectrograms. Spectrogram is a visual representation of the spectrum of frequencies of a signal as it varies with time. When applied to audio signals, spectrograms are sometimes called sonographs, voice prints, or voicegrams. When the data is represented in a 3D plot, they may be called waterfalls. So it is kind of a audio in which there is a hidden answer. So for this, I am going to use a tool called Sonic Visualizer. I have installed it already on my Kali machine. It is not pre-installed in Kali. You have to Google. Uh, you can simply Google any tool for spectrograms, and I'm going to use this Sonic Visualizer for this task. Okay, I will include the link for the download of Sonic Visualizer in the description of this video. So let's download this audio file first. Okay, I think is let's move it to our folder first. Here. Okay, so Sonic Visualizer. Let's open our file now. Okay, new version is available. So Kali, let's open this audio file. Okay, let's play this. Let's check the hint first. Audacity. Let's Google this. Okay, it is also a multi-track audio editor and recorder for Windows. Let me see if I have. No, I don't. I don't think I need this anymore. I'm using Firefox. Let's head over to Google Chrome first. Copy this link. Okay, why it's not. Let's try strings on this. Audacity. Okay, let's install this. let's try task 3. Then steganography is the practice of concealing a file, message, or image, video within another file, message, image, or video. So it is kind of like hiding something, a hidden text inside an image, file, or anything. So let's download this file first. Okay. It's taking too much time. First, flag. Let's move that file to my folder first. So first of all, let's try to read the metadata from this JPEG file. Okay, so the exif tool. So we don't find anything useful in this metadata. So I also know a tool called stag hide minus minus. The syntax for using this is minus minus extract minus sf and the file name. Sometimes it asks for, I mean every time it asks for password, but let's as of this image we don't know any password, so I'm going to just press enter because I don't know any password. But in most cases you have to know a password to use this tool. This is asking for enter passphrase, so I don't know any password here, so I'm just assuming that it will work without any password. So yeah, it worked. Wrote extracted data to this text file. Let's cat this text file first. Spaghetti is seg. Spaghetti is seg is the pass is the hidden image, hidden password you can say inside that image file. So the last one is security through obscurity is the reliance in security engineering on the secrecy of design or implementation as the main method of providing security for a system or component of system. Download and get inside the file. What is the first file name and extension? So let's download this file first. Has it installed Audacity? Okay. Audacity. Let's upload our file here. I think it is in home. I think this is the secret wave audio file. So let's play this. I have no idea what this is. Let's try any online spectrographing tool. Spec- Let's try this spectrum analyzer. It is something is written, but I can't read it. It's what was the? It consists of three words. Okay, it's not visible from here. So let's upload the file here. No, it was in. So let's. Okay, now we can see that word. It is super secret message. So all I did was just, instead of, I think it was treating it as a waveform, and all I did was just said add a spectrogram, not a waveform. The waveform was quite blurry and it was not visible, and when I did this add spectrogram, and now the answer is quite visible. It is super secret message. Oh, it was super secret message. Right. Why it's not working? Okay, it is working, but it was a bit slow. So we don't need this anymore. Sonic. So Sonic Visualizer also worked. So it only worked, but the hint said something regarding Audacity. It's not closing. Okay, so we completed three tasks, and the last one is security through obscurity. Okay, so I think we have downloaded that file. Have I? Let me see. Meme.jpg. Maybe this is the file. I think so. Let's see again. Yeah, meme.jpg is the file. So let's move it to our folder first. Move slash root slash down slash me. So what I'm doing here is I'm moving a file from our downloads folder to my current folder, and this is the syntax for this. You have to just place a dot. This dot represents that I want to move this file from that previous location to my current location, that is home slash kali mfv slash capture the flag. And you don't have to type the whole meme.jpg. You can if you don't have any other file with the same name, then you don't have to type the whole name. You can just type me, and tab will auto complete the rest of the code. So this is the file meme.jpg. Download and get inside the file. What is the, let's run binwalk to see if it has some other file inside it. Meme.jpg. Okay. Binwalk. I guess minus e is the syntax. I think so. It doesn't look good, so let's simply run strings to check. Let's run strings on this file. Let's see. Okay, we found me. Hackerchat.png is the file inside it. We didn't have to do anything, just I ran simple strings. It what strings does is it prints out all the characters inside a file. So it wrote this is the file inside it, and this is also a text. You found me with that file. So get inside the archive and inspect the file carefully. Find the hidden text. We have already found the hidden text. Okay, so we have completed this. So let's see what did the hint says. What did the hint say? Okay, obscure stag. It is saying to use stag. What was the file? Stag. Maybe we should run. It was saying to run this file, like stag hide on it as well. So we all know the syntax at stag hide minus minus I mean dash dash extract dash sf and the file name, and it asks for a password, but we don't know any password, so could not extract any. That's what I'm talking about. It's saying it cannot extract that data with that passphrase because it requires a password. Did it say anything about password? Stay. So anyways, we have completed this as well. Answer is case sensitive. We've completed this, so let's try this spectrogram with Audacity tool as well. Okay, so let's add this file. It was this. Okay, so I guess it is. It was to spectrogram, I guess. It was to convert. Analyze. So I'm not finding the exact option here, which is to convert the waveform into. Okay, let me see this. Actually, I'm not finding that option here to convert it into a waveform. But we did it with sonic visualizer, so I don't think it's necessary. But I wanted to show you to do the same thing from the, you can say, uh, the made path, the actual path that was made through which this file had to be done. But we also did it using sonic visualizer, so I think that, so I think we also did it using sonic visualizer. So but but the hint said try using Audacity. Never mind, we have completed this room, and that's it for this video, and thank you for watching.